It's the summer solstice, which in AppSec terms is the longest data and the shortest buffer. It's also a chance to reimagine Bananarama's synth-pop hit Cruel Summer from the perspective of an API with lyrics like, "Strange voices are saying things I can't understand. Is too close for comfort. This code has got right out of hand." Which means this week we talk with Nuno Loureiro and Tiago Mendo from Probly about strategies for web scanning and creating useful solutions for developers. In the news segment, supply chains dance with integrity, iOS trips over a network name, an authorization bug strides into a $30,000 bounty, CodeCov waltzes past Bash, and more. Sit around and stay tuned for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. We discuss application security a lot on this show, and we know that the implications for code security have become even greater as cloud adoption accelerates software development. Shift Left bridges the gap between security teams and developers to find and fix vulnerabilities accurately from the source. Shift Left Core is an innovation in code security with industry-leading accuracy and speed. It combines next-generation static code analysis, intelligent software composition analysis, secrets detection, security insights, and contextual developer security education in one easy-to-use platform. Learn more and create your free account at securityweekly.com/shift-left. Are you looking for a solution to protect your web apps against the most business-critical security vulnerabilities? Unleash the power of automated ethical hacker knowledge with Detectify for continuous coverage and relevant security vulnerability findings. Upgrade your web app security with speed and scale and start a 2-week free trial at securityweekly.com/Detectify. Go hack yourself. Whether you need to manage bots, protect cloud applications at runtime, stop formjacking attacks, or secure your web applications and APIs, only Imperva offers a unified solution to protect from edge to application and data in one tool. Imperva helps you achieve more, save money, and become more efficient with fewer security vendors needed. Start a free trial today to easily protect your apps and website with Imperva. Learn more at securityweekly.com/Imperva.
This is episode 155, recorded June 21st, 2021. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John.
How you doing, sir? Almost the end of June.
Almost the end of June, exactly. End of June, start of the summer, and start of the winter for our Southern Hemisphere listeners, which hopefully there are some listeners down there. Let us know in Discord. Because you can also stay in the loop on all things Security Weekly by visiting securityweekly.com/subscribe to subscribe on your favorite podcast catcher or our YouTube channel. Sign up for a mailing list. Let us know what hemisphere you're in our Discord server, and follow us on our newest live streaming platform, Twitch. Also, join us June 24th at 11 a.m. Eastern to learn how web application firewalls can help mitigate exposure in a complex threat landscape. Then join us July 15th at 11 a.m. Eastern to learn how a thoughtful approach to SASE can improve security and enable scalability. Visit securityweekly.com/webcast to register now. And if you missed any of our previously recorded webcasts or technical trainings, they are available for your viewing pleasure at securityweekly.com/on-demand. Nuno is a co-founder and CEO of Probly. In the past, he led an application security team at a telco provider where he provided training on secure coding, security guidance during the development lifecycle of products, performed penetration testing, and implemented PCI DSS across the organization. We also have Tiago with us, who's a co-founder and CTO of Probly, a cybersecurity startup that does web application security scanning as a service. He has 17 plus years of experience in information security as a builder of web app security teams, a programmer, and a pen tester. Hello, Nuno and Tiago. Thank you for joining us.
Hi.
Hello. Hello, Mike. It's a pleasure to be here.
It's a pleasure to have you both here because the three of us have talked in the past a little bit about application scanning and how much fun and challenging it can be. So it's fun to have you all here and have John joining us as well to talk about DAST and building not only scanners that can work with modern web applications, but scanners that actually work for modern web application development, meaning they're actually usable by developers or usable by security teams for that matter as well. So I think there's a couple different ways we can approach this, but maybe let's start off with just some of your background on, pen testing, what you've seen in testing the security of web applications, and how that has differed, or how web applications have evolved into what they look like now, and what makes it harder or perhaps easier to scan web applications in a modern day.
Well, I guess that applications these days, or the what's so-called modern web applications or single-page apps, raise a new challenge, especially for scanning them. Since mainly the application itself is just one page, like a big JavaScript file or a set of files that runs in the browser and then usually calls an API in the background through AJAX requests, and basically these new applications, like a page is not really a page. So it really depends on how developers implement those applications as well. Like if they have permalinks to each page, let's put it this way, to each screen of the application, each section, and since it's more JavaScript rich, basically, like the application is also more complex in terms of events, things that happen in the DOM dynamically, and basically that creates a challenge for scanning them.
Yeah, so there's a lot of what you're describing is the complexity of that state within the application, and as you said, is getting ceci n'est pas une page. If we're going to call out this is not a page. And I think also, too, we've seen this bifurcation, if you will, this split even with OWASP, where we have the OWASP Web Top 10, but also API Security Top 10. So tell us a bit more about when we are as developers, or even the security team, building web applications, building APIs, and we want to scan them. Are there certain things that, either from the scanning perspective, we want to make sure that we're setting up the scanner properly so it can succeed, or will it succeed against this particular endpoint? Or maybe we can look at that from the angle of, what's different in the APIs as well from the web applications. I'm just trying to get a sense of just what does the universe of things to test out there look like from a web security perspective.
Yeah. One of the biggest challenges for Dust scanners, for Dust solutions so far, has been authentication. And the problem has only increased, especially with single-page apps and all the JavaScript and single sign-on and multi-step logins. But actually, I think for API scanning, the authentication, it should be easier. Most of APIs just require a token, like a fixed token, an API key, or they get a variable token from a specific endpoint. So actually, authentication should be easier for API scanning, but that's one of the first things and most important things you need to set up. And then the other, in my opinion, is how well you parse the API schema. So for web applications, you need to crawl the application, find all the routes, trigger all the JavaScript events, get to all the points. In APIs, you get that for free. You get the schema. But then you have an issue. You still need to honor the schema with regard to the fields, the inputs. So if the schema says it's a string, we need to pass a string that matches the requirements, and that might be a challenge. So giving contextual information for that API that makes sense, like a name here must match these requirements, it's a challenge, and it's probably the most important thing when you set up like for API scanning. Not sure if you agree or not, Nuno.
Sure. Actually, I want to complement your answer with when we talk about developing a mix of both. Like, I think what you're referring to is more scanning APIs and scanning web apps. But when you mix both, there's actually a few more challenges from a development perspective. For instance, the authentication is actually one of them. Usually developers are used to develop or implement authentication on a web application, on an isolated web application, on an isolated API. But when you mix both together, I guess a lot of developers or a lot of people got confused on how to correctly implement authentication in this mixed scenario. And like, for instance, I can tell you briefly, like one of our clients, one time I was helping them, and they had a single page app that calls an API, and it was actually related with cryptocurrencies. And I was looking at the API to see, like, in terms of authentication, like what do you have, if you would have to configure something on Probably or not. And then I realized that the API didn't require authentication. It just blindly trusted the requests made by the web application. And I don't know, the developer thought that maybe he didn't need to implement authentication on the API. I don't know. But there's definitely some new challenges when you're mixing both, because the APIs usually, like the authentication for APIs, if you're talking about backend communications or computer-to-computer communications, usually use a fixed key. And when you're talking about web applications that call APIs, you need to implement authentication in a different way. It needs to be more like session-based. And that, I guess, presented some challenges as well for web application development.
So I think there's an interesting aspect there too, is you kind of, as you're describing, like having the schemas for APIs, the schemas are giving you lots of context, saying these are the types of data it's expecting. You were mentioning a string, and it could be numbers, it could be emails, etc. And Nuno, you were just explaining too that from the authentication perspective, ostensibly an API is going to say it's expecting an authentication token, and you can kind of figure out which ones are decorated with you should be authenticated and which ones don't need authentication. And then hopefully you can figure out, for those that don't need authentication, maybe they should have. So is there an angle here that the types of vulnerabilities that you're able to find with this type of scanning is we're shifting a little bit more away from cross-site scripting, SQL injection, which I'm going to cross my fingers and hope we don't see that much of anymore, at least on the SQL injection side. And we're looking more at authentication and authorization issues. Sort of what's kind of that mix of the vulnerabilities you're seeing within APIs?
Go ahead, Tiago.
API scanning with a schema, with access to the schema, in this case the APIs, puts us in a better position for finding authentication, authorization vulnerabilities, because we have something that clearly states these endpoints require authentication, which is something we have to figure out while crawling the web application. So here we have an opportunity to, we know beforehand these endpoints requires authentication. So we could try to do some tests, like trying with different users and see if the information is the same or not. Because we can try to assume that if it requires authentication, it should be accessing information specific for that user. So this opens a path for improved tests for authorization checks, authorization IDORs, and so on and so forth, that with web applications are much harder to set up. It's much difficult to test for those. And as you said, cross-site scripting for APIs one can say that might not even make sense because the API, the response still need to go to the JavaScript to handle it. Yeah, I think authorization, we are in a better position to find authorization vulnerabilities with API scanning, for sure.
For sure.
You were saying, Nuno, something, or?
No, I think you said pretty much everything. It's just actually I've seen some APIs that the response is just HTML in the response, and those like you can have the cross-site scripting, yeah,
with the right content type, yeah.
And SQL injection, Mike. And SQL injection, Mike, is something that you still see a lot, unfortunately. and something that we shouldn't be seeing a lot by now, especially after all the frameworks and languages have prepared statements. But the truth is that there's still a lot SQL injections out there, and we see a lot more than what we expected.
So with the comment around HTML responses, you just led into something I was thinking about. How does GraphQL affect this? So, I think the vast majority of us who do anything with an API at all, we're used to just, standard Ajax type stuff. Starting to see more GraphQL over the last year or two. How either, do you guys support that, or what's your thoughts around how do you do scanning on a GraphQL system?
GraphQL brings us some challenges because it might hide multiple backends and multiple databases in a single layer. So that definitely can create some confusion because we are more used to, as a pen testers, as security testers, to test for, SQL injection and assume when you find one, there's a single backend, a single database behind. And with GraphQL, it's much harder to find those in general because you need to inject something that is valid for GraphQL and it still be valid for the backend part, and that might give a false sense of security to the developers, to the ones that maintain the backends, because maybe most attacks are being blocked just because we use GraphQL, like a middleware hiding the details. So it's not that the backend is not vulnerable. It's really hard to get the right payload through. And those same endpoints could be exposed internally or to a partner without the public GraphQL, and so they might get attacked. We do parse GraphQL and inject with limited capabilities on those endpoints. But as I said, it's hard to get past. It's hard to find a payload that matches all the technologies in the pipeline until from the front ends, from the request to the end of the line.
Yeah, it sounds like very much like a classic just approach in general, like with fuzzing. You need some amount of valid data to bypass the validators, to reuse the word, in order to exercise what might be actually an authorization problem or some other type of issue. I'm kind of curious too, Ben, let's sort of bring in the user side of this, that developer side, or even the security team side, because if we're thinking about just the APIs, the GraphQL, I would hope at least still there's some from the developer's perspective, they're building some unit tests, some functional tests to say, is this even working correctly? And then what a DAST or other type of scanner might come in and do is saying, can this be abused or misused in ways that are surprising or unexpected? So as you start to bring in these types of tools, do you tend to see a trend with the shift left, of the modern day AppSec, of developers trying to take advantage of these types of scanners much more, or are they security teams that are pushing this, or what seems to influence how security testing is adopted within APIs or web applications?
Do you want to answer, Nuno, or yeah?
Sure. Well, I think that having an easy integration with the tools that developers use helps in that process a lot. It's possible for development teams to be performing security testing without actually doing anything regarding that. For instance, if you start or if you trigger scans with your CI/CD tool, and for instance, you have synchronization with Jira, for instance, where all the issues are synced with Jira, and developers just receive magically the reports of vulnerabilities found on the Jira project, just like any other bug or task. And then at the end when they fix the issue and they close the issue, that triggers a retest on Probably side. And if it's not properly fixed, it will reopen back the issue on Jira. And that's one aspect. Of course, there are many, but just by the fact that you're integrating with the developer stack, it just helps them to perform security testing in a seamless way.
Yeah, but I think development is not well, at least from what I see, is not as mature as you are putting it, Mike. Like if developers are creating unit tests with the security purpose, from my experience, and yeah, developers create unit tests, but there's still a huge lack of tests for failing situations, for bad input. So they typically the time is a scarce resource. So the few tests that exist are to ensure the feature passes, it works. So it normally misses those typical textbook cases. Okay, let's order a beer. What happens if I order a beer -1 beers or A beers? So those failing tests are still not there. And I put the security tests, unit tests on the same thing. It's like it's not required for the feature to work. It would be awesome. And actually, one of the ideas we've been discussing a lot is to, and we talked with other security professionals, is to, whenever we find a vulnerability, give the user, here's a unit test, a matching unit test for this vulnerability. So at least you could have a regression test on your CI/CD pipeline without even in a very easy way.
Yeah, we have a few clients, and we know a few security people that do a lot of unit testing, but for security. But the reality is the majority just don't. As Tiago said, it's like they want a pass. If it fails, it doesn't really matter why it fails. They just need to do something in order for it to pass, and they are more worried about passing than the reasons for failing.
Sure. Yeah. I can imagine that there's got to be then too this aspect of you have older applications, web applications that don't have owners anymore too, right? And so therefore they maybe aren't. No unit tests are being created, if any unit tests ever were. So I suppose there's also this aspect of maturity or of the org, as well as just that enumeration. What do I have out there in terms of a discovery perspective? I'm curious too, in that discovery angle, are there certain things that come up surprising when you turn on the scanner against an organization's footprint, that you start finding those dusty corners with certain types of vulnerabilities, or are there certain themes that come up when you do that type of scanning?
One of the very quickly, one of the things that surprised me the most is the file path traversal or local file include that we find from time to time, and more often than I would imagine. Frequently in in PHP applications, not necessarily older, but the frequency of we finding local file includes where we can read the whole file system. It's incredible. Like a single parameter in a single URL gives us access to the whole file system, and that amazes me that we can find those today, like with a basic payload like /etc/passwd. That surprises me.
Yeah.
Yes. Well, whether you realize or not, that's what path traversal is one of my favorite types of vulnerabilities ever. We tend to joke about it quite often here. I'm curious too, kind of on that topic, we're talking about bringing in scanning, bringing in testing. How have you seen successful ways that organizations have responded to this? Because I think, Nuno, too, you were kind of saying that in some cases, and obviously not the best cases necessarily even, a lot of developers just want to make the scan pass, and they're not asking those probing questions about why did this happen? Is there some other underlying root cause? Did we just cut and paste from Stack Overflow like we shouldn't have? Or was there something that was more flawed in the design that doesn't lock down the file system to prevent these types of local inclusion attacks or directory traversals like you were describing, Tiago? So I guess, have you seen a successful way to bring a scanner of any type into a broader program that's kind of forward-looking? What might a team or an organization do from that strategic perspective? Or is it hopeless for them and we're out of luck?
No, I think organizations, we've seen some organizations adding like a Dust to their CI/CD pipeline, and they want to add it as soon as possible in the pipeline. So there's some challenges that prevent that from happening easily, on every commit or on every branch. But the shifting these scans left to the development team, I think it's good, because imagine you are programming, you run a scan, you get feedback in a few minutes. You can easily correlate the scan results with what you just did, instead of the classic scenario where you code uncoded code, you submit for the security team, you wait for them to have time, then comes the pen test, then the report. Your mind is in a different place now. So if you get fast results, if you get scans in the pipeline as soon as possible, you get those. And if you get trained, and we have some customers that if you get trained to react to high severity vulnerabilities, because I don't know, they get the notification on Slack or something, developers feel the responsibility of, oh my God, I did I introduced a serious vulnerability, I'm going to fix it, because there's more visibility for the vulnerabilities, and that creates some peer pressure, right? That's typically visibility is good. So the scanner and the integration with existing tools brings visibility to the whole team, and that, I think, it creates a healthy pressure on them. So, and that for sure has positive results.
Yeah, and it's not the first or second time that we have clients that basically introduce like a high risk vulnerability in production, like a SQL injection, for instance, or even cross-site scripting, and like they trigger the scan after the deployment, and they catch the vulnerability, and like within 30 minutes they fix production. This happens. Yeah, this happens more often than what you'd expect. One other thing aligned with what we were discussing before is that we had some customers, like every other week, maybe not every other week, but like maybe every month, we have a customer that tells us that they found critical issues on their application in result of a scan for something that the scan didn't really identify. We are not talking about normal vulnerabilities, but something more like architectural that was triggered while the scan was running, and that's interesting as well. It means that some dev teams really have control, and they monitor, and they have more visibility of what's happening when people are attacking their applications.
No, that's interesting, because I've come across that. Oh, go ahead, John.
Sorry. That's what, as you guys are talking about this last, I don't know, call it last 5 minutes. And it'd be curious to hear a little more about the experience you've had with customers as they use your tools. From the point of view of, I think what would be sort of interesting for listeners to think about is, I'll say you have 100 installations. I'm sure it's way higher than that. Out of that, have you seen any patterns of like, is there a certain way that certain groups use that tool or use the results of the tool that they've had better results? In other words, everyone gets, 50 scan results. I'm being very generous and making that number low. But is there a way that either a cultural response to that, or is there some sort of pattern that you've seen that in some organizations, how they deal with those results has been much more effective?
I mean, the way they use the tools themselves, we see a lot of bigger companies that the security team is the one that is using the tool in the beginning, and their goal is like there's a lot of different silos, a lot of different dev teams, each one with different ways of doing things, with different workflows. And their goal as a security team is to actually offload some of the tests directly to dev teams. So the integrations part is a big step towards that, because they can just integrate, in this case, probably with their existing tools, and by having that seamless integration, it's just an easier way of for developers for doing security testing. We built probably from scratch to be more like a point and shoot solution. So we try to minimize the number of configurations that the client needs to perform in order to properly use the tool. That's one of the things that we battle every day, is to build a tool that can figure it out by itself. So in that regard, it's very easy to perform a scan and have a good coverage and good results without really configuring the tool or fine-tune the configuration of the tool.
That sounds also too like there's an aspect of success in using it that you were also describing, where when an application has more monitoring, observability built into it, and a scan is happening, perhaps the scan is causing a mini denial of service, not intentionally, of course, but it's exposing here's an area that is a bit more brittle on the API, or the API got into an error state just because it got a little too much unexpected garbage data. And that's also sounds like, I think that ties into a little bit of maybe John, the gist of what John was also curious about too, about how the tool can be better adopted or be part of just a more comprehensive approach to the question of what's going on with my application. And maybe application is also plural. I have 1, a dozen, 100 different applications. Tell us a bit more about maybe those surprising areas of what this type of scanning has exposed, that it wasn't that goes beyond just that cross-site scripting and SQL injection.
Oh, we had customers that that because the scanner probably injected a lot of payloads like a fuzzer. You can see that from a point of view of a fuzzer. They get errors on their backends or further down that they eventually can relate to some input or some erroneous state, as you said, and that customers that have monitoring in place, and it can be simple monitoring like a Sentry or something that catches stack traces. That brings them a lot of visibility, because even if the malicious payload doesn't reach the furthest parts of the application, these wrong states still trigger bad situations. And I think only if you are monitoring the application with something looking for errors, not necessarily vulnerabilities, you get even better return from security probably. And we had customers saying we see them stopping the scan, and we ask them what's wrong. You stopped the scan; it was doing a good progress, and they tell us, "Oh man, something blew up on the backend because some payload reached somewhere else, or the disk got filled up, and we didn't have monitoring." So these are cool things. They still show some immature parts of the infrastructure, but it's good that the security tool is exercising those code paths, all those things, and finding those issues. So that's a good scenario we hear from our customers when they use Probe.
Yes, finding out those types of things they're always bugs, and as long as they don't get found, I suppose, on a Friday afternoon before everybody's wanting to go home for the weekend, that's a much better situation.
No, I was saying that sometimes we get the applications into bad states because, for instance, our crawler didn't follow the expected flow in the forms. So it filled the form, then it jumped to another, or because there are multiple threads submitting the forms. So then the customers ask, how the hell did you reach that endpoint with those values? How have you found that URL? It's not listed anywhere. So that's good. That we always like when we find those because a dedicated hacker, an attacker, would probably find them also with some other tool or manually.
Yeah, and often they find bugs that are not really security related. Just as you were saying, Mike, just because they're exercising the application.
No, so I think speaking of exercising applications, looking ahead to perhaps the next year or the next couple of years, are there something that you're either really excited to bring out of the application scanning space, or are there particular vulnerabilities that you're starting to see more of that are new and different? This is something to get ahead of, perhaps, as developers and security teams are considering the security of their APIs and moving beyond the OWASP top 10, perhaps.
We are definitely going to put a lot of cards on API scanning and improve our API scanning capabilities, especially for those things that are usually not found by task tools. So you want to go, or we want to take a step forward and cover other types of issues. And one of the things that we're going to be focusing on the upcoming years is to make DAS scanners more intelligent. I think DAS scanners today, they are still a little bit dumb. Is more like brute force. It's just sending a bulk of payloads and analyze the behavior of the application. And there's a lot of improvement in the ways scans are performed, and that's definitely something that we're going to bet a lot for the upcoming years. Tiago, I don't know if you want to add something here.
No, I agree with you. Definitely, authorization and authentication issues in APIs are going to be big because I don't know. It's maybe it's a mix of having everything in front of us on a platter for us to find those vulnerabilities. Here's the schema. Here the endpoint. Here's the metadata about these endpoints. Now go and find the vulnerabilities. So that might help in making authorization and authentication issues increase. They might exist already in the same. The proportion of vulnerabilities of those type might not increase, but I think we have everything on at our disposal to find those, to automate the discovery of those.
And one other thing that we're going to invest a lot of time as well on is the crawler part itself. Crawling a modern application is still challenging. I think we do a pretty good job when compared to our competitors. We run some tests and our crawler performs really well, and we receive comments from our clients. But I think there's still a long way to go to have crawling like a human. If you want to use that expression, I think there's still a long way to go. Like the crawlers need to be a little more intelligent, need to understand what an application is expecting, the type of data, where to click, the flows of the application, and with a little bit of AI help, I think you can also make some really good progress in that front.
Oh, well, I think speaking of progress, you've made us a little bit more intelligent, I think, on this session talking about DAST and web application scanning. So Nuno and Tiago, I want to thank you for joining us.
Thank you. It was our pleasure.
Yeah.
Also want to thank John and everybody else who's been listening. To learn more about Probly, visit securityweekly.com/Probly. We're going to take a quick break and return with news of the week.
DisruptOps helps you find and fix cloud security issues fast. Getting bombarded with irrelevant alerts is frustrating. DisruptOps gives security and DevOps teams prioritized findings and routes relevant alerts to Slack or Microsoft Teams with automated response options that save you time. Finally, security is inside your workflow instead of in your way. Listeners can access the full platform free for 30 days by visiting securityweekly.com/DisruptOps. When it comes to web app and API security, the choice is simple. You can choose Fastly's security solution that teams will actually use in full blocking mode, just like 90% of their customers. Or you can stick with costly options that you probably just turn off. You can get Fastly's all-in-one platform that protects apps everywhere they live, however they're built. Or departments can agree to disagree. You can go to securityweekly.com/Fastly to learn more. Or you can just wish you had. Looking to improve your web application security? Probly is reinventing web application security. Probly focuses on the vulnerabilities that matter, eliminates false positives with evidence-based scanning, and provides a simple point-and-shoot solution that is easy to use. Probly's thorough coverage ensures accurate identification of vulnerabilities in any modern web application or API. Improve your web application security processes by visiting securityweekly.com/Probly and start your free trial today.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by John Kinsella. Security Weekly is more than happy to announce that we will be at InfoSec World 2021 in person this October 25th through 27th. This year, our annual partnership with InfoSec World is extra special, as we are both business units under the Cyber Risk Alliance brand. So, what does that mean for Security Weekly listeners and InfoSec World attendees? You will get to see and hear from many of the Security Weekly team at the event, and you will save 20% off your World Pass. Visit securityweekly.com/ISW2021 to register using our discount code. Security Weekly is also ecstatic to announce that Security Weekly Unlocked will be held in person this December 5th through 8th at the Hilton Lake Buena Vista. Call for presentations and early registration for Security Weekly listeners is open now. Visit securityweekly.com/unlocked to submit your presentation and to register for the early registration price before it expires. And this brings us, Mr. Kinsella, to the news of the week. So I know you've got something that was standing out, and this is ongoing work from Google. They've been doing quite a bit of work the last couple of months, at least in blog posts, about supply chain. And supply chain, of course, is going to be the center square of the bingo card throughout 2021. So I think it's unavoidable, unfortunately, but there's at least something maybe new we can talk about this week from Salsa. So give us a couple steps. How do we step into Salsa here?
Okay, I should have seen that coming. How do we want to go into this? I think you said it pretty well. Google's come out with this thing called Salsa, SLSA for those trying to Google it. It's an end-to-end, to read directly off their title, I'm going to be lazy here. End-to-end frameworks for supply chain integrity. I like the way you phrase it. The center square on the bingo card is definitely what it's appearing to be this year. So this is interesting. I linked to the blog in the show notes. I'm sort of in a temporary environment here right now, so I'm on my phone looking at this stuff. The first thing that really caught my visual self, there's a diagram in here where they sort of break down between source integrity, build integrity, and they actually do a pretty good job of actually showing a decent list of places where a threat actor could actually try and get in and modify the supply chain. So I think for those who need a visual reference, it's a pretty decent one. Good number of examples, including actually saying, hey, referencing code cover, we're going to talk about that in a few minutes, referencing attack on package mirrors, SolarWinds, we got to remember them, PHP, Linux hypocrite attacks. So that was the commits from our researchers before Christmas, I think. So they have a bunch of good examples, and then how this framework would have mitigated those. But I don't know, and maybe I haven't read enough into this yet. I'd love to see more meat behind it. It seems like it's just sort of a framework, and I feel like we've got a few of those already this year. So I've said this in different circles over the last few months. I think one of the problems we have as an industry right now, before it used to be all the vendors are all trying to come up with the same product, and Adrian's got a great talk on that. But now it's like a lot of these, I'm going to call this open source for right now to fit into this argument. But a lot of the different open source or standards bodies are all sort of coming up with the same standards. So, CNCF has some stuff around this. These guys do. I think Cloud Security does. I know MITRE's working on something. So there's all these different groups that are working on the same thing. So then it's like, which one do you want to pick from? And that brings you back to the joke on standards. But it is an interesting read if for folks who are trying to get their head around what do we do around supply chain. It's a good place to start. I just wish some of these guys would actually work together instead of coming up with the same thing all over again.
Yeah, I think in the spirit of in the joke on standards, on the joke on commentary as well, trying to struggle to add to something that you didn't already cover. I think the thing that I'll try to squeeze in here too is that it at least is nice how the graph as well stood out to me, that it pulls out a threat model and it's highlighting the two major aspects of here's an artifact, meaning here's the thing we've built and we've got a SHA-1 hash or it's been signed or something like that, so we can just prove that the integrity was maintained from code to commit to deploy. But there's also the process that is focusing on too, and hopefully that process is something that I know we're talking about frameworks and we need to do things, and it's not so prescriptive quite at the moment, but the process should be remembered. So because those are, as the threat model shows, those are some attack vectors into modifying the source or making sure that the integrity of the artifact that you've built hasn't been subverted in some way because of some problem within the build infrastructure as well. But to your point, the Linux Foundation has been writing a lot of things about SCIM, SCIM, SBOM. There's also the SDDF, I think. I'm trying to pull out as many of the acronym, SSDF, Secure Software Development Framework. This is also from NIST. All of these frameworks that are basically saying a lot of very similar things. Have people review code, make sure that the code that is the SHA-1 hash of the repo matches what was built and matches what's get deployed, and then adds your users, provide a way for your users to verify that this is the artifact you built. Sort of that end-to-end process. And I think we need less perhaps of just reminders of that's what we should be doing, and more tooling to help us be able to more easily say, here is the certificate transparency, if you will, of the world to show the binary transparency or binary integrity of the dependencies or of all the open source libraries that are being consumed by different projects.
Yep.
I think then you set up a pretty good segue. Let's talk about CodeCov, because I brought in this article briefly just as a callback to CodeCov. We talked about a breach and supply chain, of course. And as a quick reminder, this was a compromise in their bash uploader script where the binary that the bash uploader was pulling from was modified by the attacker. So this is a classic pipe a bash script through curl, and as long as the HTTPS certificate works, then basically curl is going to execute through that bash, install your binary, and you're good to go install either the malware crypto miner or legitimate binary of your choice, depending on what day of the week it is. What was interesting, stood out to me, was they wrote up a nice, bit of more of a postmortem, and they're also describing how and why they're switching from Bash, and in this case to an NPM, a Node.js implementation. So it's also a little bit of tie to that idea of refactoring and re-architecting that we touched on a little bit last episode as well. But I'm curious, John, if you had the choice to rebuild from Bash into another mechanism to handle this uploader, you're laughing. I don't know why you think you know what the question I'm going to ask is, but it's going to be, would you have used Node.js?
I'm glad that we think along the same wavelengths. That sort of caught my attention in this article. And so let's think about it from an engineering organization point of view. If you've got a team that knows Node, it's going to look better than Bash, right? the second thing that really made me snap the neck in there was a node binary. I didn't know those existed, but hey, that's sort of cool. No, man. What would I pick for this? I mean, it's such a simple thing, right? That I was just starting to look at the node code before this, and I didn't look at how many. I wanted to see how many imports they were doing, like how actual, talk about supply chain. How complex was this thing going to be? Because that's the problem we see with Node, right? It's not the JavaScript code yourself you're writing. It's all the stuff you bring in and all the friends and enemies that you bring along with you. So maybe it's okay. It wouldn't be my first choice. What would be my first choice? I mean, I'm a Go guy nowadays. Looking for excuses to use Rust still. Maybe even, Python. I think there's lots of choices. It depends on how complex the beast is. And the problem is not just how complex it is, but how complex it's going to become as they start adding functionality over the next, year or three. Do we need to add a coffee maker in there? And then which node libraries do we need and how many vulnerabilities do they have? So I think that's where my concern was. But yeah, that was the first thing that popped into my head.
Yeah, and I think what's the quote from Jamie Zawinski? Every software is going to expand until it supports email. So maybe the uploader will support that. But no, I think I did like their thought process. So they were clear about their thought process of the benefits of a new uploader. So they're saying that they wanted to have a compiled binary, so it makes it just more difficult to muck about with. They wanted to have it something that's more understandable, maintainable. So they were talking about that. So now, of course, we can have different discussions on what is maintainable versus Node versus other choices. But if this is what your development team knows, probably smarter to go into that rather than the magic of syntax and what that looks like within Bash scripts. So kudos to them for changing, responding, and moving things forward. So that will be just kind of an interesting. I suppose that's one example of the framework in practice. This software supply chain framework in practice of having deliberative engineering choices into how do we obtain updates and maintain that software throughout. I'm going to use this since you also mentioned Python. You're setting me up with all the great segues today. Thank you, John. I had another kind of semi-obscure, perhaps, article just talking about using the abstract syntax tree, using the AST, not to crawl it, as we were talking last episode with things like semgrep, but actually using the AST to modify a software, sort of a dynamic patching or live patching, if you will. And I thought this was a really neat reminder of why the ASTs are really neat and can be pretty powerful tool beyond just having a semgrep type of style to walk through and have good semantic understanding of, is this a variable name? Was this just a code comment? Is this a secret? Is this a variable that I care about and want to respond to, et cetera, et cetera? And in this case, just saying we have perhaps a known vulnerability, or we have a code smell or an anti-pattern that's pretty easy to identify. And rather than assign an intern for the next 2 months to go and remove and replace all of the instances of this particular code smell, we could do this programmatically with a degree of confidence. And this was just kind of a neat approach that I wanted to highlight and throw that out there for in this case for those of you approaching Python.
I think I'll talk about the positives first. So that's the
there are minefields here. Yes.
Yeah, that's the. I mean, I'm having flashbacks of having done that in the past. If you have, like, say, I don't know, 20, 30,000 lines of code and you need to do some sort of refactoring on it, that will give you flashbacks. So from that point of view, going through trouble, it's funny, right? It's the how big of a problem does it have to be before you stop doing it manually and actually go and figure out how to use a Python script like this. The example that comes to mind to me is, like, if you're doing search and replace in VI on a large file, how long until you go back and Google, okay, how do I do search and replace in VI again? But so yeah, that was interesting. The part that sort of scared me a little bit was they commented about they were doing this on, I think it was like 4 or 5 nodes that they were replacing 150,000 lines of code or modifying a pretty decent amount of code on. It didn't sound like a Git repo was involved in that. And I'm like, what, are you doing this live? So that's the part that I thought was a little weird. And maybe that's just how I'm reading the article.
Yeah, I think there's the aspects are definitely you're going into this with confidence that you have good testing, because the next best way to fuzz your software is to just change your software programmatically, or automatically in this case, and see what happens. So it's not quite a YOLO deploy; it's a YOLO patching, perhaps. But I think still a good tool to consider, but it's probably not going to be the thing that you're going to approach unless you have a pretty mature software development process and some high confidence in your testing. But still really fun things to do with ASTs. And the reason I was thinking of that is that once again, we have come across some printf family of bugs. We were shaking our heads also last episode. So for those of you who haven't caught the last episode, go give a listen, then come back. But we were talking about how just how dead simple some sprintf bugs were in actually, speaking of Python, building some command lines to be passed on to Python that were simple string concatenation. Here is a funny and quirky iOS bug that highlighted that format string vulnerabilities still exist. So format strings are, for those of you who are unfamiliar, that's basically the printf family of functions have %s, %p. You can pass these percent prefixed flags, to be alliterative, into the function parameters, and that will influence the data types that you can populate, or how they're formatted in terms of integers or decimal points, etc. And they were all of the hotness around the early 2000s, and then they did kind of disappear. And I want to say they disappeared because there's a lot of effort into expunging them from all of the vulnerable C code, and a lot of compilers and libraries did some tweaking to make those, that class of family more difficult to create as well as to exploit. But lo and behold, here was someone who created a nice and funky Wi-Fi name, connected their iPhone to it, and bad things happened. So good on you for finding a format string. Long may they live.
Yeah. We saw this about the same time last week. You got it in before me. You did a much better job in intro than I would have done. But I'm sort of stumbling for words, like how did this exist? How did this even come around? Right? It's and not so much that's bad, but how did this dude find us? I mean, for folks who haven't seen, it's what I think it's like 4 percentage characters, so %p, %d, %s, %t as an example. You make that your Wi-Fi name, and you join that with your phone, and suddenly your phone stops working on Wi-Fi. It's like, I'll censor myself, but how? What the hell is going on there? And then also, how did this dude find us? So there must be some other sort of sniff going on that these guys realize that there's something going on. I think his quote in the article was, or their quote was, he didn't specify how he found us, but obviously he was up to some sort of hijinks, right? But yeah, it's that's an interesting one. And I suspect people are a certain group of the population have realized that there might be something more interesting there, and they're probably crazily trying to fuzz that now as we speak.
No, absolutely. So yeah, I will be curious if this does engender a resurgence in looking and discovering, unfortunately, many more format string bugs, and throwing in those %ps and %ns in particular, because if you just look at the man page for printf, there's already the warning that, and I'm going to mostly quote here, that programmers are strongly advised never to pass untrusted strings as the format argument. Which not too surprising there, because an attacker can put format specifiers in the string to mangle your stack. And that's actually exactly what this %n can do as well. And that's the %n, you noted it, John. That was one of the final character here in this particular Wi-Fi network name. But it's an interesting combination, because not only do we have a function that can format a buffer to be written out to screen, but it also can write the number of bytes already printed, pop that onto your stack. So there was always an interesting way of how this type of function is a bit weird and can work in very surprising ways, because it's going to actually write back onto your stack and potentially with user or attacker influenced data. So it also threw in a PDF that gives a great history, I think, of format string attacks from 2005, if I'm remembering correctly. So encourage listeners who are interested about that and want to go start looking for this, go give that a read and start throwing in your %Ps, %Ss, and %Ns into all of the interesting inputs and see what starts to fall apart. Maybe go find some more and find yourself some bounties. Speaking of bounties and also GraphQL, so we had a little bit of foreshadowing, John, from the last segment when you mentioned GraphQL. There was a article here from a $30,000 bounty for basically what the researcher wrote up as a 4-step process to bypass basically an authorization problem within the API. And it's, again, in that category of dead simple type of attack, not to take away from how impactful it was, but just kind of showing the aspect of it can still be really hard to really easy to mess up authorization and misapply it, because this attack didn't rely on any garbage input. It didn't rely on anything that a input validation would have found. It really just relied on, oops, we forgot to apply an authorization check here, and someone found it because they were patient and diligent and demonstrated how to exploit it. One quick caveat, you do need to get a media ID, so there is a little bit of a prerequisite here, but I think clearly Facebook, Instagram were saying, nah, that's not enough of a prerequisite to say this isn't a problem, so here's $30,000. Go invest in becoming a security influencer now, perhaps.
Get that TikTok going. So I think, yeah, and that idea to be clear on it is you have to brute force that, is the sense I got from it, right? So this, one of the problems I have, I'm not a huge fan of GraphQL. It's okay, it's nice. I understand the use from a developer's point of view of, well, we can just provide an API and then, the front end guys can go and write their queries as they need to, and we'll never have to touch it again. But from what I've seen, I've used GraphQL probably twice over the last 18 months now, are built into programs. I've never had a really, really solid feeling of the libraries I was using, partially because their documentation was sort of weak, and I'm talking about the big ones, and I think one of them actually comes from Facebook, if I remember right. There's this sense of you're doing something which is powerful, but I never really felt like I had a really strong grasp of them, and I think the result of that is partially something like this, right? I'm not saying that GraphQL causes authorization issues. That's obviously not the case. But potentially people, and I would expect a company like Facebook to have very solid understanding of what they're using and what they're putting out there. I'm doing really good today at filtering myself and or censoring my swear words. But I don't know. I suspect that has something to do with it. I think there's a lot of complexity which is introduced with GraphQL. And while it can be used for a lot of great things, KISS is around for a reason. So that's I'd be very leery of bringing this into an application unless the team really understood what was going on with it.
Yeah, and I think to me, there's that aspect of abstractions can be good, but a little, if we've gotten too much of an abstraction, or if we've gone, if we've obscured a lot of the areas, if we've obscured security boundaries, that's the part where this abstraction can potentially bring in vulnerabilities, mistakes. And that's where I think it's something like GraphQL. Just use it as the example, it's not the cause here. But that we can say, here's one database has controls on its data in one method. Here's another data store that had controls and was expecting an identifier from something else in order to control access to it. And I'm starting to get a bit hand wavy here on my terms, but I think the point. Yeah, go ahead. Pull me out here.
And either Nuno or Thiago, I can't remember which one, but on our previous segment, when I was picking their brain around GraphQL scanning, they mentioned something very interesting, and it slipped off my mind at first, is that abstraction layer that you're bringing in with GraphQL, depending on which vendor solution you're using out there, you might be obscuring away more than one database. So, the end solution looks really nice and really clean, but if you just sort of take one of the vendor implementations, say, hey, I want to use these two databases, and this is my route, that could get interesting, not in a good way. So yeah, it's a lot of potential with it. It's a very powerful thing, but as we say a lot, the power brings potential badness.
Potential badness. There is also, so we're going to shift from abstractions to ancientness, and I'm going to coin a new word there. Here is another article about systemd, and this was a privilege escalation problem in it. Two things that stood out for me. One was that it was actually some newer versions of the distro that had picked up the insecure code and put it in there. So it was a little bit of a surprise just in sense of figuring out, am I vulnerable or not? And the other aspect was, here is a 7-year-old bug that has finally been publicly disclosed and is getting patched. And we've seen, 7 years, 10 years, I think up to 20 years just this year we've been talking about, or maybe it was 2020, about the email from the work from Qualys that they were highlighting on some 20-year-old bugs. But one of the things where my mind went there was, is this a good or bad sign? Or, glass half full, half empty, in the sense we're finding these ancient bugs now? Are there more lurking out there? Or maybe what's the techniques that we have that are getting better that we're finding these bugs and squashing them? And I don't know what the answer is here, but I have some ideas. So I don't know if if John, you want to dive into maybe that age aspect of this, or there was a different part of it that was standing out to you.
You mentioned having ideas. I'm like, oh, let's hear them. Let's see. The age thing was interesting. I mean, okay, yeah, great. What's interesting about it actually is that no one's found this one before. So I think a lot of us in the Linux world, we've always sort of, since systemd has been around, we've been like trying to keep that thing a little bit at distance from us and not digging as much as we probably should have to really understand it inside out. And the result of that is we now found out that they're using something other than sudo to do privilege escalation purposely to launch programs, which, okay, that's cool, but I bet you someone out there knew this. This feels like something that somebody has known and been exploiting for a while, and it's just now becoming public. That's my sense on this one.
Yeah, I'd be very curious about that. And it was also the introduction to me about trying to dive into Polkit and read about the policies. And again, there's a lot of flexibility that these types of configuration mechanisms can introduce, but it's also pretty easy to make mistakes. And yeah, I think that was just more of, it's seeing these long-lived vulns does beg the question of who else knew about them, how often have they been abused. And I guess I suppose the other thing on the top of my mind is that I'll be curious to watch maybe throughout the rest of 2021, 2022, do we see sort of this spike in long-lived vulns that are being identified through fuzzing, through code reviews, through something. And as the world is shifting to better designs, different languages, we're going to see fewer memory safety issues, or like in this case, fewer just obvious issues. Obvious, unfortunately, in after the fact, once this particular type of vulnerability is pointed out and how simple it is to exploit. So again, this is the conjecture episode. Yeah. What do you wonder about, John?
I wonder about lots of things. I wonder if some of these vulns we've seen, and in the Qualys case, obviously that's professional curiosity, but in some of these other ones we've seen like this, I wonder if this is a result of people being locked up for the last year and just starting to poke around a little more than they would have otherwise. You think maybe?
There we go. That's a great idea. I would be very curious as how many people have actually spent more time reading with code, playing with code, and so on. So it will also be nice to see, because Google has been also pushing on open source, and we're just talking about Salsa. They've been pushing. They have a open source fuzzing project that they've been running for a while. Maybe we'll also start to see the projects that they pull into that umbrella become larger. And I can't remember. I have to go back and double check on what we talked about around the open source bug bounty. There was a discussion of a bug bounty as last resort that was also just kind of a thought exercise. What would it cost to say, let's just have a bug bounty for open source, as well as I know there's Linux Foundation, I believe, has a bounty program for open source. So maybe there's some money to be made. Not $30,000. These volunteer and projects don't quite have the deep pockets that someone like Facebook has. But hopefully there's something out there to highlight more of this type of bug checking, bug bounty looking. I do have one final article that I wanted to pull in here, and it's a bit more. I didn't want to get into navel gazing necessarily, and to a degree, we use the phrase shift left just to mean early on in the SDLC, or we use the term DevOps to say shifting responsibility for developers on to take on more responsibility for security and kind of what that entails. And I don't think we really need to get into strict definitions of what shift left means or DevOps versus DevSecOps, because honestly, developers don't care. They're busy writing features, releasing code, and making it secure. But this article was highlighting, I think, a good point. It was pointing out why shift left security has become a bit of a misnomer. I would say maybe not so much a misnomer as just we need a reminder that there's a lot of software that is running that still needs to have some observability in it, still needs to have some type of security process around it, some security tooling that's monitoring it for either known vulnerabilities as they get disclosed, or have a way to identify vulnerabilities. So I think the point that I would make in response to this article is not so much put all of your eggs in one basket and everything is easier and better because you're doing all of your security checking at the development side of things as you're writing the code. But remember that for as much effort as you're putting into the securing the writing the code, there's still some deployed code monitoring that you still wanted to check on. So I think that was the not necessarily succinct way I put it, but that was what I took from this article. And we
still
can
try
maybe,
to parse my thoughts.
Yeah,
still try to parse my thoughts on this one. Sorry,
you've been restraining yourself quite well. Unleash now. Let's hear it, John.
No. This is a sponsor.
Okay.
I think, he has some interesting points. I think what I would say is we have to remember that we're in our little bubble, right? So we've got a pretty good number of listeners and viewers on Application Security Weekly, right? We're proud and happy to be here, and I love you all listening to our stuff, but we're still a pretty small fraction of the software development or security development or any of those worlds out there. So I think if you get outside our little bubble, shift left is still quite a thing. And I think it's I always talk about, I don't want to preach the security crowd. I want us to go out and preach the rest of the world. So I think what's going on here is a little bit the reverse of that. It's preaching inwards instead of preaching outwards. And I think that's where we get into a little bit of not so much nasal gazing, but we're sort of, it's the same thing as like the cloud doesn't exist, it's just someone else's computer.
Sure. Again,
I'm going to censor myself in my response, but it's that type of thing. It's like, okay, dude, fine, give it another name. It's the concept of the phrase I've started using recently, you probably heard on the show, is developer first, right? So I want my security tools to really be focused around something that developer can use if that's the end market, not just take a security tool and give it to the developer, right? Don't just give them a scanner, but give them a scanner that actually works in their environment, speaks in a language they know. The results are understandable. All those things that it's designed for being used by the developer, not by the security person. So I think that's where shift left comes interesting to me, not just the tools themselves. It's like saying that there's a DevSecOps tool. No, it shouldn't be DevSecOps. DevSecOps is a concept. So that's it's interesting, but at the same time, not too much of the navel gazing.
Yeah, no, I think putting developer first is a great reason to give you the last word for this episode. So I think that was a great way to end on. So I want to thank you, John, for joining us. Thank all of the listeners. We're going to see you again next week on Application Security Weekly.